We're going to jump into another section here just briefly and talk about some very interesting aspects as it relates to global deployment of systems like this. I kind of mentioned briefly in our opener that we're going to be looking at other regions around the world. And that's kind of why we brought Wayne onto the call. Wayne, are you there?
I'm here.
Get you spotlighted here. So Wayne, we heard from you earlier just discussing a couple different ideas and concepts about deployment in this region. And maybe you can give us a little background on your nonprofit and your mission.
Very good. My nonprofit is called Active Climate Rescue Initiative. And basically, that name in itself, it comes from thinking about all the ways that people are talking about repairing the climate, reversing global warming. And everybody is saying, well, don't do this and don't do that. Don't drive, don't burn gas, don't fly, don't, and there's a lot of don'ts. And so what we came up with is called Move the Water. And Move the Water is a do. And by just one simple thing, and it sounds, I call it simple, and you guys know because you've been working on it for I don't know how many years, trying to get water into the Salton Sea, trying to get water into Laguna Salada. That is not exactly simple, but one simple thing of digging a ditch from the ocean to a below sea level depression in a desert. The whole concept here lies on reversing global warming. And by just moving the water, I think we can do that. So here's, in general, the first thing that we want to do is dig the ditch. Reverse the flow of the Coyote Canal so that it feeds Laguna Salada instead of draining water out of Laguna Salada. Since there's no water to drain out, that shouldn't hurt too much. But by digging the canal, the first thing that we've done is we have reduced the ocean level. That's a big concern of people that are concerned with climate change, is that the ocean level is rising. Well, by taking water out of the ocean, you have reduced the ocean level. And if you go to the ocean with a 1 liter bottle and you take 1 liter of water out of the ocean and bring it home with you, you've lowered the ocean level. Okay, just a little tiny bit, but you've done it. But in a case like filling Laguna Salada, you've done it a lot more. And if you continue that water into the Salton Sea, you've done it more yet. So the first goal is met just by digging the ditch. When you think about that, then there's other things that work towards reversing global warming. And it starts this way. What happens when you put water into a hot, dry, windy place? It evaporates. Well, the evaporation is a cooling event for the local environment. You stand next to a big body of water and you get this nice breeze coming off that body of water. It's nice and cool, refreshing. That's evaporation in work. That's what's coming off there. That's why it's cool. It's evaporation. So now we've lowered the ocean level and we've cooled the local environment. But what evaporates up must come down. And it comes down in the form of rain or mist in the local area. It will come down on mountains as snowpack eventually. But it comes back down in the form of rain. We'll just use rain as our primary example. And again, if you think about it, whenever it's raining, it's cooler. Raining is a cooling event. So now we've cooled the local environment a second time, just again by digging the ditch. The only thing we did is dig the ditch. The evaporation was done through natural processes, and the rain returns through natural processes. And so we've cooled twice now. We look then at what happens wherever it rains. Well, where it rains, you get plants growing. Simple. I mean, that's, it's almost foolproof. I mean, there's places in the desert where plants, seeds are just sitting there waiting for water, and they get watered once every couple of years in some deserts. And these plants will bloom, turn their flowers, turn their seeds, drop their seeds, and dry up and go away and wait for the next rainfall. when we open a channel to the ocean and allow free flow of water into a place like Laguna Salada, you now have a constant moisture being entered into the air, and so you will have constant moisture returning to the area. And then the plants can grow constantly. So with plants growing, the plants do a number of things for the environment. The first thing is that plants are natural air conditioners. Through their photosynthesis, they release water into the air, and it's just, standing under a tree is just a lot cooler than standing in the sun. So they provide shade to the ground. So those two processes are cooling the local area. If you stand on a piece of asphalt in the full sun of this desert, or if you stand on the asphalt under the shade of a tree, you can do it barefoot under the shade of a tree, but you can't do it barefoot in the full sun. And so the ground itself becomes cooler when it's got plant cover. And when it's got plant cover and when the rain comes again, the water doesn't quickly evaporate, but it soaks into the ground. So now with the plants cooling the ground, the water can soak in. So we're storing water in the ground, and this is water that doesn't return back to the ocean. So we've evaporated water out. We've drawn water out of the ocean. We've evaporated that water, and thus we draw more water out of the ocean. And then the water rains and doesn't flow back to the ocean, but sinks into the ground and stays there. It's there to feed the plants and to it'll sink in, and it'll fill up underground aquifers that might have been dry for a long time. It'll allow those to be full. So we've now lowered ocean level, cooled the desert, cooled the desert, cooled the desert 3 times. And we're holding fresh water for human use. The plants themselves are about 50% water. And so they're holding water that doesn't return back to the ocean. And the plants are little tiny carbon sinks. And we talk about a blade of grass, but a blade of grass is a carbon sink. And trees are nice carbon sinks, but blade of grass does the same thing, only on a smaller scale. And you can have a heck of a lot more blades of grass a lot faster than you can have trees. So now you've got this nice grassy field. It's sucking carbon out of the air, and it's holding that carbon. It's using that as a building block for their little tiny plant bodies. So now we've lowered the ocean level. We've cooled the desert 3 times. We're holding water back from getting to the ocean by making fresh water for human consumption, and we're producing oxygen and taking carbon dioxide out of the air. All of this is done just by digging the ditch. And then what I like to say is just allow, eventually some of that water is going to not be used in that local area, and it's going to blow 10 miles downwind, and it's going to do the same thing. And it's going to blow 10 miles downwind, and it's going to do the same thing. It's going to blow, etc. And so by opening up a water path, gravity flow water path to a below sea level depression in a desert, you have made a huge contribution to reversing global warming, because you're cooling like crazy, and you're potentially rehydrating a large environment. In a grandiose scheme, I look at Sahara. The Sahara, in my lifetime, has been pushing the desert further and further south. There was a Lake Chad in Sahara that was just a huge freshwater lake on the southern side of the Sahara. I can envision, by implementing Move the Water in a couple of places around the Sahara, Tunisia, Egypt, Ethiopia, we could reverse that desertification and pull it north by adding water on the north side of the desert and just letting it circulate in the atmosphere, recycling itself over and over and over as it moves around the desert. The problem with these deserts is that they're in a rain shadow, and that's where the problem comes in. They aren't getting the water from the ocean, because the ocean, as it water evaporates and brings in, it pushes up against the mountain that surrounds the deserts. And when it goes up against the mountain, of course, it drops all of its water as it passes over. So the air passing over the mountain has been dried. So the desert doesn't get any water, so it's in a desert. So it's in a moisture deficit. So by getting water behind the mountains, so filling Laguna Salada with water, you're putting water between the mountains that are there. And by bringing the water into the Salton Sea, you're getting water behind the mountains again. We're circumventing the rain shadow effect and bringing the water in directly for it to evaporate directly. So those are some general thoughts about just the concept of move the water. When I think about, let's see, how much do you lower the ocean is a question. Not a lot. There's 11 places around the world that this can happen. One of the places is Death Valley. And I don't support this as a thought, but if you could fill Death Valley with water, you could lower the ocean what would be considered a significant amount. You've got the Dead Sea in Jordan and Israel. If you could bring that up to sea level, you would lower the ocean level a significant amount. Filling up Laguna Salada, not much. But it would be a continual removal of water because the water keeps being sucked out and keeps being evaporated. Eventually, it'll cycle through the system and come back, but it will take a long time and it will get a lot of use before it returns. One of the things that I see, and I mentioned this earlier, and I'll just jump into it for a minute right now, is that the problem in the Southwest USA and the Salton Sea, okay, let me try this differently. I think that your efforts to refill the Salton Sea would be greatly enhanced by working on it as a project to reverse global warming, because that will gather you support from farther out areas. Right now, refilling the Salton Sea affects the people that live in Imperial Valley. Okay, how many is that? Well, not a lot in the state of California. I mean, everyone else is on the coast, right? But if you set up the cry that, hello, if we put water here, we're going to be reversing global warming, and here's all the good ways it'll do it. You now have a lot of people that are scared of climate change living on the coast of California, don't want their houses to flood, helping you put water in the Salton Sea so that it will reverse the global warming. At the same time, by the way, bringing water into the Salton Sea and Laguna Salada is going to work to reverse the fire danger. And this is something that the people in the main part of California will care about. And I'm expecting that it will put more snowpack up in the mountains. The water evaporating off these two bodies of water will blow up there and will stop as snow. And some of that snow will go down the other side. So there is definite benefit to the state of California to work on this, and there's ecological benefit for the whole nation to work on it. But there's in the area right now, though, we know that there's a mega drought in Southwest USA and Northwest Mexico. It's got this mega drought going on. It's been going on for 20 plus years. I'm going to contend that is man-made mega drought. It's not natural. I know there's natural droughts that come and go, but this big one, I think, was man-made. And I think it was man-made by the overdraw of water from the Colorado River. And here's my very simple explanation of that. When you look at a water cycle, now when people start saying, well, we're having a drought, we have to conserve water, and they start protecting their water and start stopping it from evaporating and stuff like that. But the thing with water is you absolutely want it to evaporate. You want it to move. The evaporation process is the natural purification process. And And by it evaporating and raining, you're getting more uses out of a gallon of water than if you just covered it and let it sit there for one private use. So, but there's a water cycle as I see it. And I could be wrong. You can prove me wrong, and that's just fine. But I see a water cycle. And I see the water cycle beginning in Laguna Salada. Laguna Salada, several years ago, filled up by the Colorado River. So we now have plenty of water in Laguna Salada. Well, that water evaporates. It blows north to the Salton Sea. Again, this is overly simplified. The water in the Salton Sea evaporates, blows north into Death Valley, which evaporates, blows north into the Great Salt Lake, which evaporates, blows north into the headwaters of the Colorado River. From that point, flows down the Colorado River, fills up Laguna Salada, at which point it evaporates and blows north to the Salton Sea. Very simple, but it's a large scale and it covers a large area. So in the last number of years, so much water is extracted from the Colorado River that nothing is from the Colorado River is reaching Laguna Salada. And during that same time, then, there's nothing to evaporate. So the water cycle is broken. So there's nothing to come down the Colorado River because Laguna Salada is dry. All the water, again, has been taken for a single use. A lot of it dragged out of the watershed from the Colorado River over the mountain into California for a couple of large cities. But that water can't be used again. Now, if the water is taken out of the watershed, is taken out of the river, used to irrigate some plants there, it evaporates up and it should fall back into the river. It stays in the watershed for pretty much, or what flows under the ground will flow back to the watershed. But by taking it out of the watershed, by using these large cities and disposing of it in a place that it's not going to get recycled, you're losing that water for the water circulation. So you've broken the water cycle. There's two ways it can be fixed. One, stop taking water out of the river. Well, that's not going to happen. It's the water coming out of the rivers for good use. I mean, you don't want people going thirsty. And so, fine, just keep using it. Well, you have to find the other method. Well, the other method is dig the ditch, move the water, fill Laguna Salada, fill up the Salton Sea. I've got other things beyond the scope of what you guys are talking about, but I can foresee some effort being made to move some water from the Salton Sea to Death Valley. I am not saying to fill Death Valley with water, but if you took a 12-foot diameter tunnel from the Salton Sea to Death Valley and had open gravity flow, you'd be moving water all the time out of the Salton Sea. And it'd be ending up in Death Valley where it would almost immediately evaporate into nothing and start running around the Great Basin and rehydrating the Great Basin and filling up the Great Salt Lake and getting easier process of getting up to the headwaters of the Colorado. But the same thing you'd gain at that point is you'd gain a flow through to the Salton Sea, so you wouldn't have as much of a salt problem. And I know there's people working on fixing the salt problem, and I'm not addressing the salt problem. I know that when you bring water in, you can. Nathan, what do you got?
Yeah, no, I think this is it's an amazing conversation. So you just mentioned a couple different things. Is we have our freshwater use, right? We have freshwater that we use for drinking. Then we have freshwater that we use for throwing it on the ground to water grass. And then we have freshwater that we use to flush our toilets. So there's this gradient, right? And when we talk about water policy, there is nothing more than we have fresh water. We need to use fresh water. And I kind of mentioned, because it's here in my home, but I did a study for Mission Bay. We have about 1,016 acres of turf that we pour fresh water on, and we spend a lot of energy and create a lot of greenhouse gas emissions by moving water around California to throw on the dirt. Mission Bay is right next to the ocean. We have a source of water, it's the ocean, and we can pour that ocean water on the dirt and grow salt tolerant grass. They're using these in Florida right now where they use it, and if they're using it on a golf course, it has many different species, a variety of density. So that you can use this for any kind of grass anywhere. here at what is it called, SeaWorld, they deployed, and I was part of the permitting process, but they deployed the use of ocean water to flush their toilets, right? Like all of these different technologies are, what is our water policy? Do we want to conserve water? Do we want to do something different that has equal the cost? Or in this case, if we talk about Mission Bay, the taxpayers here in San Diego, we pay $1 million annually to throw water on dirt. We pay another 1.5 for those maintenance people to maintain that dirt or that grass. So when you're talking about the financing mechanisms, that's $1 million annually for 1,016 acres. And I actually took that to the mayor and, got the response that it was too complicated, or, it was a little bit outside of the normal. But that is going to be the response, right? It takes visionaries like, Norm is here. He's worked with Ned Doherty in the past. We're going to have Christian talk about seawater grass and seawater farming. But, that policy, once you take that around the world, we can say in Salton City, we can have a seawater tolerant golf course. We can have seawater tolerant agricultural products. We can have seawater tolerant residential grass or commercial landscapes that aren't just grass. So it's really this mild shift and a monumental shift after that proof of concept that ocean water is our most valuable resource. And once we understand that, then all we need fresh water for is to drink and to grow freshwater tolerant crops. There's other things, but those are the predominant uses of fresh water. And once we start doing that, then ocean water can be everything else. I wanted to get back to the point that was made on how much this would affect. When we get to the point that Wayne made, which is when you deploy here at Laguna Salada and you keep the Salton Sea full, that's a little bit of a dent. It's the same thing as a glass of water. When you start flooding and using ocean water around Laguna Salada and around the Salton Sea, that's another dent. And so these are just different layers that you have to add on over the course of our next 100 years or 200 years, where we start to deploy it in the Danakill Depression. We start to deploy it in other regions around the world. And I'll just show quickly, because I love playing with this map. This was something that we did just briefly. Google Earth is a great place that we can start tracking some of this information. Hey, we can grow fuel here. We can do wind farming here, but then we can go and launch a global effort, and we can start deploying things here in Africa. We can start deploying things here at the Qatar Depression. And this is exactly what Wayne was saying, right? This is a small dent, the Qatar Depression. It's been studied by other people around the world. It doesn't have that same benefit that we're talking about with evaporation as it relates to adding water around Africa or Egypt. It kind of goes off into the ocean again. But this percolates into the ground and it evaporates, and you get the benefit of doing some green agriculture around it, and anywhere really that's in that region.
Let me jump in just a second.
Please, yeah.
The area around the Qatar Depression, if the wind blows to the north, you're going to be blowing up a mountain. And so you're going to be drying the air as it leaves the area, which means you're going to be keeping the water behind the mountain. That would be one thing. But the other thing is you haven't looked at Tunisia at all. I don't see that on your area. Tunisia is another important area. It's easier to get water into Tunisia than it is any place else in Africa. Tunisia is right on the north, right along the Mediterranean. Go about halfway across the top of, right in that little dip right there. Yeah, there's a dip in the mountains right there, and you can bring. Let's see, I think maybe it's a little bit more to the west yet, but there it is. There it is, right there. There's a dip, and there aren't mountains, and you can easily bring water. I mean, they've got below sea level places there. We can bring water there. There's a number of areas that are below sea level. They get water right now, but they dry up in the summertime. So they'll fill up in the winter through percolation from the ocean, from the Mediterranean Sea. and then they dry up rather rapidly when they get summertime. But if they could keep an open channel, they would be able to provide moisture all year round.
Absolutely. Yeah. No, that's great.
I'd like to add a point real quick.
Just real quick, Rob, that what he's saying is these are small depressions. There's coastline all along each of these areas. So not only does the coastline become viable, but these depressions become viable. Go ahead, Rob.
A particular issue. Now, I'd really like to stay focused on Laguna Salada and the other locations there. But a big issue there in Laguna Salada and our regional project is that you have a very effective, large, essentially catcher's glove. Got to understand that water vapor itself is a more powerful greenhouse gas by quite a long shot than CO2. If you release it into a place where it's going to become hot and muggy, say like Louisiana, with no big mountains kind of close to it, we don't want humid air staying around too long. The good thing about the Danakill Depression right there and or the Colorado Rockies, it's maybe a half a day for the wind to blow the moisture uphill far enough to where it condenses into clouds. In this location, you have the Ethiopian Plateau and the Simeon Mountain Range that are directly to the what would that be, west of the Danakill Depression. And generally what happens in this region of the world, which is very close to the equator, is that essentially hot, dry winds blow off of Saudi Arabia over the marine boundary layer that exists on top of the Red Sea and come to ground in the Danakill Depression, making that very evaporative. So evaporation from there is forced uphill, condenses, and you have a lot of thunderstorms there that actually flow directly down into the Sudan via existing river channels. This is kind of like one of the ancient sort of riverways that was cut away by rains from a wetter past time. But from Sudan, you do a lot of farming in Sudan. Wind blows it further to the west and right over to that lake, the Chad Lake, or that lake there in Chad, just below and to the left of your hand, Nathan. Yeah, right down. No, keep going. To the left, right there. I think that's it. But there are a couple of lakes right there that go along. Essentially, what you're going to do is you're going to have two monsoons going in opposite directions. On the southern part of the African continent, water comes in from what's on screen there is the Gulf of, I'm not sure how to pronounce it.
Djibouti. Yeah.
Yeah.
I'm going to jump in for just a second here, Rob. I've got a hard break that I have to make at 7:00, and I'm showing that it's 6:59 my time. So
no, yeah, that's
I've
great.
got to roll. I did put in the chat. I put a link to the couple videos that I've got up on this. The other thing that I'm going to put in the chat is one thing that I'm trying to do to help to help get this done is I'm trying to raise some money via the nonprofit so that we can get the scientific studies accomplished. There's a couple of those proposed, and I'd like to see if we can get those funded, and that would help with whatever government officials want to look at this stuff. If we can get that stuff to put in front of them, that's got to help. So those are the things, the YouTube videos I've worked on, and this funding project. If we can get that funding project done, I think it'll help a lot in moving water into the Salton Sea and into Laguna Salada. There's everything to be gained by doing it, and I can't see everything to lose by not doing it, really. So.
Absolutely. Well, thank you, Wayne, for joining. We really appreciate all your content, all of the conversation. I mean, it's really important just on many different levels. So we appreciate you joining the conversation, and we'll keep continuing from here. We had a question in the chat that we can cover. Let me just join in here. Just on a side note real quick too, we, both Rob and myself, we looked at what was happening in Australia several years ago when they were having the massive fire season. And, is there a solution there where we can create monsoon cycles? Rob's solution, which I thought was extremely creative, was creating a berm system that would keep some of the hot waters in here and reduce some of the water that's melting from the glaciers below, and keep some of that hot water in here that would increase the monsoon cycles in Australia. So really these technologies are ubiquitous again. It's just a matter of what kind of systems there. So Francisco, his question here, let's just read that out loud. Francisco Zamora, his conversation was about the Laguna Salada, wettest monsoon season. Just see, it was filled for several years in the 80s. What happened to the basin? Is there evidence showing increased snowpack in the upper basin? So yeah, and Rob answered that question. That's kind of where we started this kind of corollary conversation as far as, can we see if there's an impact or a correlation between when Laguna Salada was flooded and what effect that had on the basin. So this was flooded, and we see that there was a correlation of advanced or more than the typical amount of water in the basin at that time. We're going to also share some of those videos that Wayne had. We'll probably do that maybe tomorrow or the beginning of Friday, just to share some of that information. And hopefully we can kind of continue that conversation. We have Oliver on the line. Oliver, Wayne, and us, we're all working to fund your study. We're very excited to look at the regional climate models as proof of the pudding, right? And we're excited to deploy that in other regions once we get this proof of concept off the ground. Weather conditions. Right, the weather conditions here, a big component that we were looking at was the weather conditions of bringing water into Laguna Salada and recirculating that water back around and out into the Sea of Cortez actually helps that sweet spot of when the monsoons actually get triggered. So if there's a fraction of a degree of temperature increase with Laguna Salada circulating water back around to the Sea of Cortez, that could actually have the triggering mechanism for enhanced monsoon cycles too, but also less severe monsoon cycles where they're more prolonged and less intense. So that's an interesting part of the component that we wanted to bring forward with that concept.
Well, I would definitely like to leave that to the PhDs. We can increase evaporation, especially year round. One thing that I really learned, I live in Prescott, Arizona. And one thing I really learned this year in a big way is places like Colorado get their biggest snow when the low pressure zone and jet stream drop down towards San Diego, meaning the jet stream flows directly over Laguna Salada, the Salton Sea, on its way up directly into the Colorado River Basin. A question I'm going to end up having is, all right, how much moisture or northern Gulf moisture is entrained by those winds and that storm flying over it? Dr. Mitchell and folks at the Desert Research, others, their essential model deals with sea surface temperatures in the northern Gulf of California when they go from like 29 to 30 degrees Celsius some number of days after June 1st, typically somewhere between 30 and 45, I think. Essentially, the air above it gets moist enough and hot enough that it attains a critical mass of buoyancy, which breaks through a local boundary layer by heavier, drier air allowing that monsoon to start. Perhaps we can make it a little earlier. We'll see. But we'll leave that to those experts.
Yeah, and that question Francisco asked again was, that probably is by different factors during that time period. We don't know until we study it. And that's kind of what Rob was mentioning. We're going to take a deep, hard look and have two different agencies look at what that is. So we're excited. We're ready to launch our next portion of the conversation. Here with us again that we heard earlier is Mr. Kerry Morrison of the Eco Media Compass. Thanks for sharing your music earlier. That was really nice break from us talking and